Hello everybody, this is Sam here with DexPlayer.com, and I hope you're doing good. Today, we're going to be talking about smart contracts. Stay tuned. Okay, so here we are, and let's get right into it. First of all, I'm just going to show you the overview here. First of all, I'm going to speak more generally about what a smart contract is and why is it useful. After that, I'm going to go over the specifics of smart contracts when they are applied to decentralized exchanges. I'll go over the ERC20 token structure, the state variables, the transfer function, the approve function, and the transfer function in the TransferFrom function. What is a smart contract? A smart contract is just a computer program that runs on a blockchain technology and that self-executes once certain conditions are met. So a good metaphor for a smart contract, a famous one, is the vending machine. The vending machine is like a smart contract in the sense that it will self-execute once certain conditions are met. And these conditions are, first, enough money for the item that you want, and secondly, the right selection for the item that you want. And when these two conditions are met, the machine will automatically execute and give you the product that you asked for. Okay, so why are smart contracts useful? Smart contracts are designed to automate agreements or contracts without the need for intermediaries such as banks, legal systems, or any other third parties. It makes the processes more efficient. It makes the processes predictable because the interpretation is not made by humans, it is made by computers, and computers are deterministic. Also, it makes the agreements more transparent because it is published on a blockchain which is decentralized and is public. Now, I don't think smart contracts are only for decentralized finance. It can be used across almost any industries. So what I predict is going to happen in the next few years is that a lot of companies are going to implement smart contracts to their needs. They're going to reduce their costs, remove intermediaries, save millions of dollars, and make their business a lot more profitable. So this is why I think smart contracts are so powerful, and this is why I think they have such a bright future. Now, at DexPlayer, we're not interested in doing that. What we are interested in is to understand smart contracts very well so that we can analyze them and detect if there's fraud or if there's things that are not supposed to be there so that we can give our clients an output about that. So now you have a better understanding of what smart contracts are at a high level. Now we're going to go a little bit more into the specifics of how they work when it's applied to decentralized exchanges. Okay, so here I want to go over the ERC20 token structure. The ERC20 is a standard that dictates certain variables and functionalities that a smart contract must implement in order to be valid. So state variables that the ERC20 standard must implement are symbol, the name, decimals, total supply, the balances, and the allowances. For the functionalities, you have the transfer function, the approve function, the TransferFrom function, and the balance of function. Also, the ERC20 token will have an address on the blockchain, which is represented by this hexadecimal number here. So here I want to go over the state variables. So the first one we have on the list is name. So this is used for representing the name of the token. It's just some text, for example, Dogecoin. The symbol is an abbreviation for the name. In this example, we have Daj, so it's just some text as well. The next one is decimals, which is an integer. For example, 2. So this is used for representing the number of places used for representing fractional tokens. After that, we have the total supply, which is an integer as well, and it represents the total amount of tokens that can ever exist for a contract. After that, we have balances, which is a dictionary, and allowances, which is a dictionary of dictionaries. So I'll explain in the next slide what those are. So what's a dictionary? A dictionary is a collection of keys and values. So the first key here, so these addresses represent a dictionary, and the address 1 is the first key, and the value is $500,000. The second key is address 2. The value is $200,000 all the way up to address 10, which is the 10th key with the value of $10,000. Now for the allowances, this is a dictionary of dictionaries. So the first key of the dictionary is spender 1, and the value is all these keys and value, address 1, address 2, all the way up to address 10. The second key of this dictionary is spender 2 with the value of, and the value of spender 2 is this dictionary. So the collection of the keys and values of address 1, address 2, all the way up to address 10. Okay, so here I want to go over the functionalities, and I'll start off with the transfer function. So here at the top, we have a signature for the transfer function. And in computer science, a signature is where we declare our function, we declare the name of it, we declare the parameters that it takes in, and the values that it returns. So here, the name is transfer, the parameters that it takes in is an address and an amount. So the address is the receiver address, and the amount and the value is the transfer amount. And the return value is a success flag. So it's a Boolean. So it's a true or it's a false. It's a 0 or it's a 1. So if the function succeeds, it will return true, and if not, it will return false. And the person calling the transfer function will be the sender address. So in this example here, we have address 1 that calls this function and puts into parameters address 2 as a receiver address and $10,000 as a transfer amount. So calling this function, the function returns a success flag. So a new block will be created on the blockchain and the balances will be updated. So here, address 1 has $10,000 less and address 2 has $10,000 more. In the second example, it's exactly the same situation, but address 2 tries to send $600,000, which he doesn't have. So the transfer function returns it returns a false. So it's not a success, it's a failure, and there won't be any new block created, and the state variables will just stay the same here. So this is it for the transfer function. Pretty simple. Okay, so now I'm going to go over the approve function and the transfer from function. These two functions go hand in hand together, and they are used when an owner address wants to allow a spender address to transfer tokens on its behalf. So the approve function needs to be called before the transfer from function. And so here is the signature for the approve function. It takes into parameter a receiver address and an allowance amount, and it returns a Boolean, so a success flag. So in this example, we have address 2 that calls the approve function on Daj with receiver address will be 2, and the allowance amount will be $50,000. Now this function returns a success, and on a new block on the blockchain, the allowance for spender 2 will be updated to 50,000. So now spender 2 is allowed to transfer 50K worth of token on behalf of address 2, which brings us to the next function, the TransferFrom function. The TransferFrom function is used by usually the spender when he wants to move tokens from the owner's account to another recipient's account. This method, this function can be called by anyone, but it's usually used by the spender. And in this example, we just want to illustrate that anyone can call it. So in the example, we put the address 10. So the parameters for this function is the sender address, the spender address, and the transfer amount. And the return value is a Boolean, so it's success flag. So the address 10 calls this transfer function, puts in 2 parameters, address 2 for the sender address, address 1 for the spender address, and 50K for the transfer amount. Now, since the spender 2 has been allowed 50K, this function will return a success, and it will transfer the token to the right address. So as we see here, the address 2 has 50K less, and address 1 has 50K more. Also, the allowance for spender 2 went back down to 0 because it transferred the allowance that the amount that it was allowed to. Okay, and the last thing is the balance of function that we saw in the overview. This function is a read-only function that's used to read the balance of an address. So that's it, guys. That was my presentation about the smart contracts. I hope you understand them well. I hope you like the video. So if you have anything that you don't understand, write it in the comments and I will answer you. Also, if there is any subject that you would like for me to cover, you can ask it in the comments and I'll be happy to make a video about it. So that's it. Have a good day and until next time.